ठीक है? So next part that we'll discuss is programmable logic controllers. Okay, programmable logic controllers. Okay, now you know what is the meaning of controller. In the previous part we have seen what is the meaning of controller. What is the importance of controller as such? If you take an example of a four-wheeler, can you tell me what are the different controllers that we do have? Yes? Can we imagine a vehicle without a steering? What does the steering do? Yes, it controls the direction in which the vehicle should be moved. Okay. Can we imagine a vehicle without a brake? What it controls? It controls the speed. Okay. So role of a controller in every system is very much important. Right? Now as far as the controllers are considered or control actions are considered, we have seen that the control systems are of two types. One is open loop control and second is closed loop controller. Okay. I think we had a lot of discussion regarding what are the benefits of open loop controller, closed loop controller, where the open loop controllers are being recommended, where the closed loop controllers are recommended, etc., etc. Okay. Now the programmable logic controller, it is basically a controller. If you look at this particular word, it is basically a controller. So obviously it is going to control the system. Now when we say that the system is to be controlled, means what we exactly do? We control the different parameters into the system. Right? We are controlling the vehicle. So how the vehicle is being controlled? Either vehicle will be accelerated or vehicle speed will be dropped down. Okay. So if the vehicle speed is to be increased, what we do? We put an accelerator. It ultimately provides the more fuel supply to the engine and then we get a more power which ultimately tends to increase in a speed of the vehicle. If at all I want to control the speed, I have a brake with me. Okay, so basic role of a controller is it controls the different parameters which are ultimately affecting the system performance. This is one thing. Correct? Right? Now, why it is called as logical controller? It controls the parameter. Are you getting me? It controls the parameter, but the parameters are controlled within certain logic or with certain logic. With certain logic. Okay. For example, we have a controller for the elevator, what we call as a lift. Everybody has traveled in the lift. Correct? Right? Now you might have seen that. Suppose you are on the third floor and you want to get down to a ground floor. So what you call the lift? Right? You get into the lift, you press the ground floor button. Right? Now once you press the ground floor button, you are on the third floor, and let us say after you press the button, somebody on the fourth floor will press the button. Okay. So can you tell me where actually the lift goes? Either it goes to fourth floor, which is near to the third floor, or it goes to a ground floor. It goes to a ground floor. Are you getting me? In fact, the fourth floor is very near to the third floor. The ground floor is quite at a far distance from the third floor. But what is the logic? The logic is that first of all I am getting into the lift, I am pressing the button. So whomsoever is pressing the button, first of all the priority is given to him. Correct? Now let us say that you are getting into the lift, you press the ground floor button. Okay. Somebody who is on the fourth floor, he presses the fourth level button. Okay. And after that somebody on the second floor presses the second floor button. So what is going to be the execution of the lift? Yes, it stops at the second floor, because the controller come to know, or controller is knowing that after the third floor, the second floor comes. Are you getting me? The sensor doesn't matter. It is second floor, third floor. For him, it is same. First floor, second floor, third floor is same. Okay, but the logic which is incorporated in that particular controller in such a way that when the button on the second floor is pressed, the signal will be sent to a controller that the second floor is below the third floor. Okay, so on the way when the lift is moving from third floor to ground floor, it will definitely stop at the second floor. You will take that particular customer or whatever is there, that person will be getting into the lift and then the lift goes down. Are you getting me? Look at this particular sequence, look at this particular logic. Controlling is being done. Are you getting me? The system is controlled, but that controlling is happening with some logic. Are you getting me? Okay. Now if we look at the programmable part, we will see afterward, because that needs other information that I will let you know. Now we know that nowadays the automation is being extensively used in industries. Now can you tell me where the automation is actually recommended? Where actually the automation is recommended? Can you tell me which thing we can automate? Can we automate the moving of the car from X place to Y place? Suppose you want to develop a car, automatic driving car, who can travel from Pune to Mumbai automatically. Is it possible? Is it possible? Yes or no? Practically it is possible. Practically it is possible or not? It's not possible. Are you getting me? Because the variables are changing very frequently. Are you getting me? The variables are changing very frequently. That means if the X car is moving from Pune to Mumbai, its driving style will be different. If the Y car is moving from Pune to Mumbai, its driving style will be different. Because even though the traveling is happening between Pune to Mumbai, but the way the driver drives the car is quite different. Are you getting me? That means the driving style is not getting repeated. Are you getting me? Okay. And where do the automation is recommended? The automation is recommended where the repetitive actions are happening. Are you getting me? You might have seen the robot which are being used for pick and place. That means for material handling system. Okay. So what it does, it pick up the material. Okay. Then it rotate like this. Come down. He leave the material. Again, it comes to original position, pick up the material, go to second position, it drops the material. Okay. So this is the repetitive action which is happening. Okay. Right. So robot arm is there, which is equipped with the sensor. Right. That particular sensor will detect the position of the object. That object will be picked. Then as per the programming which is provided to it, it moves through that particular distance and angle. It drops the material and again it comes to original position. Okay. So automation is recommended where the repetitive actions are there. Are you getting me? Okay. And if you look at the use of robot or automation where the repetitive actions are there, and if I am going to depute a person, a human being to deal with that particular work, then automatically the fatigue will come to a human being. Why we are getting bored? If the same things are getting repeated again and again, so we are getting bored. Are you getting me? Or the human being is subjected to fatigue. Whereas the robot, the same thing can be done by a robot for millions of times without any loss of data, without any inaccuracy. Are you getting me? Okay. So you might have seen that the automation is exclusively used where the repetition is required, or the process consists of a repetitive action. 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. And that too based upon certain logic. Okay. So wherever automation is there, the PLCs are highly recommended over there. The PLCs are highly recommended over there. Okay. Now PLC is basically a controller that you can program. Are you getting me? PLC is basically a controller that you can program. Right. So it is a controller which work under the certain logic. That logic can be changed, that logic can be altered by using a programming. The programming which is being used for a PLC it's much different than your C programming, your Java programming, your other programming languages. Are you getting me? Okay, so there comes an exclusive process for programming the PLC that we are going to see afterward, right? So it is basically called as a programmable logic controller because it controls the various parameters into the system which is based upon certain logic. That logic can be changed again and again. That's why it's called as programmable. Okay, so the use of these PLCs in industries are extensive. All the automated systems are consist of a programmable logic controllers. Even in our laboratory also we have two setups which are basically using this PLC. One is the setup of automatic level controller. Are you getting me? We have a tank and the level of the water is to be controlled within certain limits. Okay, so that particular task will be done by the PLCs. There are the set of sensors, level sensors, who will detect the level of the water, and if the level is to be maintained within the two level sensors, 1 and 2. Okay, so during practical we'll see what exactly is being happening. And the second setup you might have experienced, that is the automatic bottle filling plant. Have you seen it? Okay, so how do the automation is happening in that particular case? The bottle comes to a particular position, a specific amount of the liquid will be filled in that particular bottle, and after that the bottle go to the next station and the next bottle will come to that particular position. Okay, so this is what is happening. So all this movement, starting of the conveyor, starting of the cylindrical wall, again stopping of the conveyor, and all these six particular actions are happening, and that control is being done by the PLC. Are you clear about this? Why it is called as a programmable logic controller? Are you clear? Okay. Now, if we look at the general layout of PLC, it is like this. At the central we have a PLC who is the main brain of a control system, you can say, or main brain of a automation. Okay. Now on this side you have got input. On this side you have got an input. Okay, right? Now we know that for any controller, if you see the general diagram of controller, on left hand side there is a input, and that input will be processed by the controller and then output occurs. Okay, so very similar to that, the PLC being basically a controller, on left hand side you have inputs. Now what are these inputs? These inputs are nothing but your sensors and the transducers. Sensors and the transducers. Okay, depend upon what is your requirement, whether you want to monitor the flow and control it, whether you want to monitor the velocity and control it, whether you want to monitor the temperature and control it. Based upon that, wherever the parameters that you need to monitor, that particular sensors are going to work as an input, and that all sensors are coupled to a PLC. Okay, that all sensors will give the instantaneous value of the inputs, that parameters, to a PLC. Right? Now this PLC is on other side, it's connected to the outputs. On other side we have an output. Okay, so what does PLC do? PLC take all the input parameters, the value of the input parameters, it will be processed. Are you getting me? Now it will be processed based upon certain logic. So you have the second input to a PLC, and that is nothing but the logic. Are you getting me? Temperature sensor, let us say this is temperature sensor. The temperature sensor will keep on monitoring the temperature in certain container. Okay, but what is the range of a temperature that you want? Are you getting me? What is the comfortable range of the temperature that is needed for your system, that you can incorporate through this particular block? Okay, so the PLC will come to know that this is the instantaneous value of the temperature which is within the limit or out of limit or less than limit. That will be done by providing the logic. Okay, so the logic to the PLC is being provided through a programming. How we can incorporate the logic into the PLC? It is through a programming. Okay, so we have a special programming software or special programming method for programming of the PLC. Okay, after the input will be processed by the PLC, the output will occur, and on output side you have the actuators. You have the actuators. Now can you tell me some actuators that you know? You have solenoid valve, correct. Then we have motors, correct. We have different motors. What are different motors? Servo motors are there, stepper motors are there. I think in the first unit we have seen that. Okay, on other, any more actuator that you know where the output can be observed? We have listed out all these outputs last time. You have lamps, correct. Lamp, light, that is also one of the output, right? Suppose some indication is to be given, the temperature, if the temperature is crossing some safe value, indication will be given, some red lamp will glow. Okay, so who will decide whether the temperature is within the range or out of the range? This PLC will decide. Okay, so based upon the temperature value, PLC will process it based upon the logic, and output will occur, that is not, but it will glow the lamp. Okay, either if the temperature is within the limit, a green lamp will be on. If the temperature is crossing a particular safe limit, red lamp will become on. Are you getting me? Okay, and we have alarms. Alarm means sounds. Okay, you might have seen that somewhere if the problem with the systems are there, a specific alarm will be given. Okay, so that ultimately takes the attention of the operator, that fetches the attention of the operator, and the system makes him know that there is something wrong going with the system. So ultimately the operator will go to the machine and he will change whatever the parameters are there, and then he will ensure that the things are okay. Okay, so these are nothing but the set of the outputs which are generally connected to at the output side of the PLC. Clear everybody? Okay, so this is a general block diagram of a PLC, and of course on this side you have a power supply. Okay, PLC is basically electronic device. PLC is basically electronic device. Okay, so for actuation of any electronic device, what you require is the power. Clear everybody? Okay, so this is nothing but the generalized block diagram of a programmable logic controller. Programmable logic controller. Are you clear everybody? Right? So input side PLC, output side the PLC is being fed with the logic which is done to a programming, and what is being done is that the PLC will take the input, it will process the input through a logic, and output will occur that will control ultimately the actuation of this all output devices. Clear everybody? Okay, now let us go to the next part, which is very important part, that is the programming. How the PLCs are programmed. Okay, PLCs are programmed, as I said, not by using any programming languages, but there is a specific method to program the PLC, and that basically, that particular method is called as ladder diagram. That particular programming is done through a ladder diagram. Okay, so what is that ladder diagram? That we'll see. Okay, now as far as whatever the part that we have discussed, the questions which are likely to be there in examination is like, explain the architecture of PLC, or with the help of block diagram explain what is the meaning of PLC, or what is the importance of PLC, or maybe like explain the function of a PLC with the help of block diagram, how actually it works. Okay, so you can draw the diagram whatever we have drawn, and we can explain that on left hand side, input, output, PLC, logic, programming, and vagara vagara. This is the generalized information that you can incorporate. Okay, now we'll go for the next part, and that is nothing but your programming. Programming of PLC. Okay, again you have a question on this particular topic, is that explain the ladder diagram with the help of suitable example, or explain how do the PLCs are programmed. Okay, now whatever we are going to see, it is basically called as the ladder diagram programming. Now practically what is happening is that the PLC is nothing but a small hardware. You might have seen in the lab also. Okay, it's basically very similar to a microcontroller, right? And that PLC you can interface with the computer. The computer is being provided with the software to prepare the ladder diagram. Are you getting me? Okay, so what you have to do is that whatever the logic that you want, that logic you have to design by using a ladder diagram, and that entire program you have to transport to the PLC. It is like uploading the program to a PLC, right? And then the PLC will execute that program. Now how the program is executed, that we will see right now. The PLC will execute the program. When it executes the program, he will come across certain logic. Okay, and then as per the logic, the output action will occur. Maybe starting of the solenoid, stopping of the solenoid, maybe starting of the conveyor, stopping of the conveyor, giving the alarm, stopping the alarm, blinking the light, stopping the light, or something like that. Okay, so all these actions, the output is going to occur by the PLC based upon the logic which is incorporated in the ladder diagram, right? And for example, you want to change something. That means, for example, the solenoid valve that is being used in a particular system, that is kept initially open for 10 seconds. Okay, now you come to know that 10 seconds is not sufficient. You want to increase the timing. Okay, so there is a timer equipped with the PLC. So what you can do is that you can only change the timing, and then automatically solenoid now, instead of it becomes open for 10 seconds, it will become open for 15 seconds. Are you getting me? Okay, you don't have to change the solenoid as such. It is not needed that you have to change the solenoid. So no physical changes into the systems are required. Whatever changes you want in an entire system, functioning of the entire system, can be only done by just changing the program. Are you getting me? And that's why PLCs are called as soft-wired automation. It is a soft-wired automation. It is not hard-wired automation. Just by changing the program, you can directly change the functioning of the system. All right, clear? Now how the PLCs are programmed? The PLCs are programmed by using a ladder diagram, or it is also called as ladder logic. Now first of all, see what are the components of a ladder diagram. Okay, the ladder diagram essentially consists of two vertical lines. See, this is very important. The ladder diagram consists of two vertical lines. Okay, and these two vertical lines are called as power rails. These are called as power rails. So this is an input power rail, you can say, and this is a output power rail. Power rails. Okay, so this ultimately represents the input energy which is given to the system or different components of your system. Okay, right? And it consists of some horizontal lines. It consists of some horizontal lines, right? Now this particular horizontal lines are called as rungs. Rung. Okay, so this is rung 1, 2, 3, 4, 5, 6, like that. The programming, the number of the rungs in a programming in the ladder diagram can be 5, 10, 100, 200, depend upon what is the complexity of the system. If thousands of the sensors are connected to the PLC, so there will be thousands of the rungs which are going to deal with the PLCs. Are you getting me? Okay. So there is no limitation on the rungs. Depend upon the capacity of the PLC, depend upon the specification of the PLC, the rung can be increased up to 100, 200, 300. That depend upon what is the logic that you are incorporating. Right? Now each of this particular rung is equipped with the what? A certain logic. Okay, each of this particular rung is equipped with a certain logic, right? So this is equipped with logic 1, this is with logic 2, this is with logic 3, like this. Okay, now the region between these two lines, that is the left power rail and the right power rail, is divided into two sections. It's divided into two sections. See, this is very important part. Okay, now this section is called as input section. That means whatever the component that you want to represent as a input to the PLC, it may be some sensors, it may be some transducers, etc., etc. That all should be graphically represented on the left hand side. Okay, and this particular side is called as the output side. So whatever motors, solenoids, alarms, lamps, whatever output devices are there, they are represented on this particular region. Okay, now a most important thing or most important input is that there can be number of inputs either connected in a parallel or the series, but there is going to be only one output which will execute. Are you getting me? There you can have a number of inputs which will simultaneously give a input to the PLC, but all that will result in single output. So you will never find that so many outputs are connected to in this particular region. There may be so many inputs present in this particular region, but here the output is going to be only one. This is very important parameter. This is very important information. Are you clear, everybody? Okay. Now, the inputs which are there to the PLC, there is certain nomenclature. There is a particular nomenclature being used for the ladder diagram, for drawing the ladder diagram. All the inputs are represented in terms of switches. All the inputs which are either it is temperature sensor, or either it is a flow sensor, or either it is a position sensor, or bagara bagara. Okay, so all that are represented in terms of switches. Now switches are again of two types. One is normally closed switch and one is normally open. Okay, the switches are basically of two types. One is normally closed and normally open. Now what is the meaning of normally closed and how it is represented? It is represented like this. This is called as normally closed. That means this switch is, if the input is not given to this switch, if the switch is not being activated, normally it connects the input side to the output side. Normally it connects the input side to the output side. Okay, you can see when the input is connected to output, when this A is connected to B. Okay, now if you see this particular structure, the A is by default connected to a B through this link. Okay, there is a spring. Now if at all you want to detach the A and B, what you have to do is that you have to press this. Are you getting me? You have to press this. So when you force this, ultimately the contact between A and B will be break. And now no input is connected to the output. Are you getting me? Okay. Now, so this is basically called as a normally closed. That means this switch is normally closed. It normally connects the input to the output. Okay. Now second type of switch, we have a normally open. Now how do the normally open is going to work? It is like this. This is normally open. Okay, generally or normally by default there is no connection between A and B. There is no connection between A and B. Okay, whenever the input is given, this is also equipped with the spring. Whenever the input is given, at that moment will be A and B will be connected. Are you getting me? At that moment only A and B will be connected and the input is now connected to the output. Okay, so this type of switch is basically called as normally open. It is normally open. It normally by default doesn't connect the input to the output. Whenever it is being activated, whenever it is being pressed, at that moment your input and output will be connected together. Take the example of this switch. Are you getting me? Okay. So this switch normally we keep it off. So when I make it on, when I actuate this, what happens? The power supply is now connected to the fan and the fan is going to run. Are you getting me? You might have seen that we have certain push-pull type of buttons. Are you getting me? Okay. So when you press it, you might have seen it. Okay. Or we know that we have a bell, doorbell. Doorbell is there. It is normally closed or normally open? Normally closed or normally open? It is normally open. Are you getting me? The doorbell is normally open. So when we press the button at for that moment, what is going to happen is that yes, it will be closed, and now power goes to that bell and then we have a sound. Correct? So doorbell we have a normally open. When it is actuated at that moment, the power input and output will be connected and then we have certain action. Everybody? Okay. Now these two things, that means normally closed switches which ultimately represent any sensor or any transducer, or a normally open which again represent the sensor or the transducer, both of them can be represented on this particular region, which is nothing but the input region. Okay, now how to represent this? This normally closed switch is represented with the symbol like this. Okay, this is the symbol for normally closed switch. Okay, so this is nothing but your input and this is nothing but your output. So you can see there is a connection, by default connection happening between input and output. When the switch is activated or when the input is given by the sensor, at that moment only this contact will be break and no power is being supplied from input to output. By default it is closed. Are you getting me? By default it is closed. But when the output is given by that particular sensor or the transducer, it becomes open and then the next process happens. Okay, now if you look at this normally open switch, it is represented like this. It is represented like this. Okay, so normally there is no connection happening between A and B. Whatever A and B I have shown over here, it is same A and B over here. Okay, so this is input side and this is output side. So normally no power is being transferred from input to the output. Now whenever the connection is being made, are you getting me? Whenever that sensor is being actuated, then only the connection will happen between the A and B, and then the power will transfer from input to the output. And then maybe just like we have discussed that a bell will ring, are you getting me? Or some lamp will glow, or some motor will be started, some cylinder will be started. That is different issue. Okay, so whenever you are giving the input, at that moment input and output will be connected and the action will happen. Clear about this, everybody? Okay, so if you actually look at any ladder diagram, you will find that there are the combination of this type of the switches, either normally closed or normally open. Okay, so if you see this particular region, which is nothing but inputs region, it is full of the combination of NC and the NO, based upon what is the logic that you want to incorporate. Correct? Okay. Now, what about the output side? Okay, all the outputs in a ladder diagram are represented by a circle. All the outputs. Either it is a motor, either it is a lamp, either it is an alarm, either it is a solenoid, whatever you want to represent it, all are represented in the form of circle. Okay, so this is the input and this is nothing but the output. Okay, so on this side, if I want to draw, there may be, you can have this kind of switches. On this side you have a circle. Okay, so both of them, if you look at this, both of them are representing the input and this is representing the output. So if you see any ladder diagram, on left hand side you will find that the combination of normally closed and normally open switches are there, irrespective of what type of input is there. That means either it is temperature sensor, velocity sensor, displacement sensor, flow sensor, or vagara vagara, that all can be represented in terms of only normally closed, normally open or normally closed switch. And whatever your outputs are there, it may be solenoid, motor, lamp, alarm, that all will be represented in terms of a circle. Are you clear, everybody? Okay, so these are nothing but the different components of the ladder diagram. There may be a question that explain the different components of the ladder diagram, or explain the ladder diagram with the help of suitable example, right? So what you can do is that you can explain the ladder diagram consists of two vertical lines which are called as power rails. Okay, now this is basically called as the input power rails, because if you can see that on this side all the inputs are connected. Okay, so the power, the energy which is required to stimulate that input components will be given by this particular line. This you can call as a common power supply to all the inputs which are there. Okay, and the second one, the vertical second line that we have on right hand side, it is basically called as the output power rail, because all the output which is occurred, which is given out by these output devices, will be presented in terms of the power rail. Okay, so output will be observed at this particular end. That's why it is called as the output power rail, and this is input power rail. Okay, now why this is called as ladder diagram? Very interesting. Why it is called as ladder diagram? Because if you look at the structure of this diagram, the diagram is like ladder. Are you getting me? The diagram is like ladder. That's why this is called as a ladder diagram. And that's all. There is no technical reason behind it. If you look at the structure, it looks like a ladder. That's why it is called as a ladder diagram. Are you clear, everybody? Okay. Now we will see through a small examples. We'll go for a very basic examples and then see how particular ladder diagram can be created by using a certain logic. Okay, right? So in the examination, if you see what is there, in examination you will be provided with certain problem that a system is there which consists of this parameter which need to be monitored, and then if A is on, B is off, vagara vagara. So that sort of logic will be there, and then you have to design the ladder diagram for the same. Okay, right? Now one more thing I forgot to tell you is that in ladder diagram we know that we have a rungs. So many rungs are there, which ultimately the horizontal lines. Now what is happening? The rung will be executed one by one. Are you getting me? That means if this ladder diagram I am going to transfer to a PLC, how do the processing is happening? How do the processing is happening? The processing is happening one by one. Okay. So first of all, the logic which is there for the rung number 1, it will be executed. Are you getting me? Okay. It is very similar to that. We have a programming. We are writing down the program through a sentence. Right? This particular logic will be resolved. Then second logic will be resolved. Then third logic will be resolved. So very similar to that, in the ladder diagram also, the processing is happening like this. First of all, the logic which is related to rung number 1 will be resolved. The output will occur. Then it goes to a second rung. The output will occur. Then it goes to a third rung. The output will occur. Okay. So the logic is resolved. The logic is executed in a sequential manner. First rung, second rung, third rung, fourth rung, like this. Okay. So this is a very important part as far as the ladder diagrams are considered. Now we will see how to prepare a ladder diagram for a particular program. Now you can note down small example. A motor